Alright, welcome to the second part of slope, and we're going to talk about the slope formula. In the first video we talked about rise over run, and we use this rate of change ratio, the change in the dependent variable over the change in the independent variable. We talked about rise over run, where the change in the dependent variable was the change in your vertical motion, because dependent variable is y, the y's depend on x. There's another way we can write this. Let's say we have 2 points. I'll call one of our points x1, y1, and let's say we have another point, x2, y2. Alright? So those are little, the ones and the twos are just little sub numbers. They don't mean anything other than the fact that we're talking about this is the first point and this one is my second point. So we have x1 and x2 and y1 and y2. We can talk about the change in the vertical and horizontal motion or movement with these two terms. So let's say we had 2 points that were on a graph. We don't know what they are specifically, but if I wanted to figure out the difference or the change in height between my y variables, I could take y2 and subtract y1 from it. So, just like that. Same thing with my x's. Let's say I wanted to figure out the difference between my x coordinates, because that's going to give me my horizontal motion. So I can take x2 and subtract x1 from it. And we get this formula, y2 minus y1 over x2 minus x1. We should probably put a minus in there. Looked kind of like an equal sign. Anyway, this is the formula that can give you the slope of 2 points that are on a line, or the slope of a line. So let's actually use this here. Slope is always given, it's called m, and you'll see what that looks y. It's given that, or not y, but where that comes up in future formulas. But here's the slope formula, y2 minus y1 all over x2 minus x1. So just for review, if we wanted to find the slope of a line that contains these 2 points, they wouldn't even give us this graph, but I just want you to see what this looks like. Using what we already know, we could do a rise over run to figure this out, and it should be a negative slope. Let's run first. We go over 1, 2, 3, 4, 5. We go over 5, that's my run, and then we're going to go down 1, 2, 3, 4. Alright, so negative 4/5 is the slope of this line. If we use the slope formula, we're also going to come up with negative 4/5 for our slope. We have to choose one of our points to be the first point and the second point. A lot of people will just make this one their first point and this one their second point. Remember, x's come first, y's come second. If your first point has an x1, then y1 has to be with that. If x2 is with one of your x's, then y2 has to be with that point as well. And we'll plug this stuff into the formula. I'm going to take y2 minus y1, so there's y2, and there's y1. I'm going to take 2 minus negative 2. And then I'm going to take my x2 minus x1. So negative 1 minus 4. And we get 2 plus 2, which is 4. And negative 1 minus 4 is negative 5. And we get the same slope that we got over here. We did rise over run. So whenever you have a negative, like we do here, you can just bring that right out front. So negative 4/5. It can go with either the top or the bottom. Doesn't matter. It still makes that slope negative, which makes sense because our line is decreasing when we connect those 2 points from left to right. So that's how we use the formula. You're going to find out that the order in which we subtract doesn't matter as long as we subtract in the same order. So for instance, let's say instead somebody made this, we got y2 minus y1, x2 minus minus x1. Let's say somebody chose this to be their second point. So here's x2, y2, x1, y1. So then we would take negative 2 minus 2, and then I would take 4 minus negative 1, and again we will get, okay, so negative 2 minus 2 is negative 4, and 4 minus negative 1 is 5. We still get negative 4/5. So it doesn't matter which order you subtract in as long as you keep that order consistent. So that is how we're going to use our slope formula, and that's about all I'll show you right now, because we'll expand on this tomorrow as well as rise over run.